Functions. If you are given any question under composite functions, you should get it correct because it's something very simple. So let's say we have x squared plus 3x plus 5. This is a function, okay? This function has been defined for you, and then I asked you to find, or you are asked to find f of maybe x plus 2. This is a function you are given, and you are asked to find this. So the basic assumption here is that if you look at this very well, what did we see in this bracket? We saw x, and then what we saw in the bracket was squared multiplied by 3, so plus, then multiplied by 3, then plus 5. So you're just going to follow the same procedure, okay? It's like a rule has been set for you. So f of x equals x squared plus 3x plus 5. Now you're asked to find f of x plus 2. So what do? You follow the same pattern. What did we see in the bracket here? It was x. Now we are seeing x plus 2. Here, whatever was in the bracket, it was squared. 3 times of it was added and 5 was added. So here too, whatever we see in the bracket, we are to square it, then plus, you multiply it by 3, then we add our 5, then we go ahead and simplify. So it's as simple as that. So now, let's look at composite functions. So you have f of x equals x squared, and then g of x equals x minus 3. I'll define this function for you. I'll define this one for you. And after that, I'm asking you to find f of g of x. So this is read as g followed by what? F. G followed by f. So you have to start with g. So the f of g of x is equal to f of g of x, like this. Just listen to the name. How did I read this? G followed by f, or f of g of x, f of this. And we know of means multiplication. We can also denote it by bracket. So f of, that's a bracket, g of x. Now we go ahead, f of, now what is our g of x? Our g of x is what? X minus 3. So we fix in the x minus 3. And now we are having f of x minus 3. So we go to f of x. Whatever was in the bracket here, it was squared. So now here, so whatever is in this bracket, we have to square it. So that's giving us x minus 3 all squared. And then we can simplify this. Square the first one, this times that, and square the second one. So this is f of g of x. As simple as that. This is composite functions. So I'll give one more example and then we look at something else. We are given f of x to be equal to x squared minus 3 and h of x to be equal to square root of x plus 1. And you are asked to find f of h of x. So you know this is equal to f of h of x, like this. Then now, what is h of x? You are going to substitute that. H of x is root of x plus 1. So f of root of x plus 1. Then you can go ahead. You look at the function of f of x. X, whatever was in the bracket, the x there was squared, then 3 was subtracted. So we follow here to, we square whatever we are seeing in the bracket, and then minus 3. So this cancels that. We have x plus 1 minus 3. Simplify, we have x minus 2. This is our final answer. If they go ahead and say find f of h of 2, then now, since you found this to be that, you just substitute your 2. That will give us 2 minus 2, which will give you 0. You could have also done this in another way. You could have substituted the 2 into this function first, and you get root 3 before you come and proceed. Let me just do that. So you could have done it this way. So you get f of, then h of 2, you are going to find h of 2. That will give us square root of 2 plus 1. This will give us f of square root of 3. And now we have this. F of anything, we square, then we subtract 3. So that gives us root 3 squared minus 3. And this will give us, this cancels 3 minus 3, we get 0. So either way, either this way or that way, you get the same answer. So that's composite functions. So I believe that you can all solve any question that comes in your IA regarding composite functions. Now let's quickly look at how to find the inverse of a function. How do you find the inverse of a function? When you are given a function and you are asked to find the inverse of that function, you equate the function to y. When we did quadratics, we established the fact that y also represents a function. So instead of saying f of x equals blah blah blah, you could have said y is equal to blah blah blah. So let's look at inverse of a function. Let me just take an example, then we solve. So f of x equals 3x minus 2. Then we are to find f inverse of x. This is the inverse, what we are looking for. So you equate the function to y. Now, interchange x and y. So wherever I see x, you make it y. Wherever I see y, you make it x. So now you have x equals 3y minus 2. Then now make y the subject. So make y the subject here. We have x plus 2 equals 3y. I cross this. So dividing through by 3, y will be equal to x plus 2 on 3. So the process of you equating the function to y, interchanging the position of x and y, making y the subject, you have found the inverse of y. So if y was equal to f of x, then y inverse to be equal to what? F inverse of x. So you found the inverse now. This has to find the inverse of a function. So I'll take one more last example, then we are good to go. If this is very, very helpful, kindly like and subscribe for me. Thank you. So f of x equals x plus 4 over 2x minus 5. Let's find the inverse of this. So y equals f of x. This implies y equals x plus 4 over 2x minus 5. So wherever I see y, make it x. Wherever I see x, we make it y. Then now you make y the subject. So this is a fraction. This is over 1. You cross multiply. Yeah. So I think we have to expand this. 2xy minus 5x equals y plus 4. And we need to group like terms. So y is here, y is here. Let's bring this here. And let's send that here. Then let's factorize y out. And we can divide through by 2x minus 1. So this whole process was like finding the inverse of y. So therefore you have found the inverse of the function to be 5x plus 4 over 2x minus 1. Now if you go ahead and find the inverse of this inverse function, you are going to get the function back. So f inverse of x will give you f of x. So inverse of a function, composite functions, any question that will come over there in your IA, you're getting it correct. Thank you.